This week's word of the week is going to be cast iron. Cast iron is a material that is poured into some kind of mold for a type of casting. I always think of like an engine block is a typical cast iron part. They make very intricate shapes with these castings that otherwise, if you were trying to put it together by welding or machining, it would just take forever. This is a very quick process. It's a good material. A couple of facts about it real quick here. The carbon has to be greater than 2%. Usually it's way above 2%. That's a huge amount of carbon to be in like a steel. Cast iron has got a lot of carbon in it. That's one of the main facts that you need to know about it. It's also brittle. This is why you have to do a lot of cast iron repairs because it can't take an impact. If you hit cast iron with like a hammer, it's just going to shatter like a piece of glass. So there's a lot of times cast iron parts are in need of repair. So they're brittle, which goes hand in hand with low ductility here. Pretty much the same thing, it doesn't bend. Short sparks, dark red. That's a spark test that you can use to identify cast irons. You just take a grinder and a spark test. You just take a grinder, you hit the material, and you look at the spark, and the type of spark that comes off will let you identify the material. It's a very old way of doing things. A lot of times it's difficult to do. With cast iron, it's very easy. You can see it's dark red, and we'll actually go out in the lab and we'll do a spark test on a piece of cast iron and low carbon steel, so you can see that here, kind of towards the end here. Different types of cast irons. It's gray, white, malleable, ductile. Most common. The most common is by far the gray. The way you identify gray versus white is the break. So when you break it, where it's broke, it's either going to be gray or it's going to be white. Now, as far as repairing cast iron goes, it's very difficult to weld cast iron. White cast iron, forget about it. We're going to cross it right off. It's unweldable. You're not going to weld white cast iron. A lot of times, white cast iron will get confused with like pot metal, old toys and things like that. It's a white metal, and people always call it pot metal. It's just garbage. It's not white cast iron. It's pot metal. White cast iron gets confused quite frequently with pot metal. Pot metal is just junk. Gray, malleable, ductile are considered to be weldable. There's a lot of things you have to do to actually weld this and have it not crack. Because of this high carbon content, it's prone to cracking on the toes of the welds, things like that. Preheat, peening, there's a whole bunch of stuff that you need to do. I'm going to actually do a repair video here next week, so you can check that out if you want, on how to actually repair a piece of gray cast that I got off. I got a door off an old wood stove and the hinges broke off it, so we'll fix that. But for now, let's go out and we'll do our spark test so you kind of see the difference between low carbon steel versus a cast iron spark. What we've got going on here is this is a wood stove door, and I got a block of low carbon steel here. And what I'll do is I'll grind the low carbon steel first, turn the lights off so you can see it better, and then I'll hit the cast iron so you can see the difference in the sparks. Shooting this way, hopefully you'll be able to see it pretty well that the cast iron has red sparks. We're going to start with the low carbon steel here, and you'll see it's much brighter yellow compared to darker red on the cast iron. So we'll start with the low carbon steel and then we'll hit the cast iron. That's low carbon, and now we'll hit the cast. Hopefully that gives you a better idea what cast iron is, how to identify it, and like I said, I'll be doing a video on how to fix this door here next week. So the spark test is pretty clear with cast versus low carbon steel, so I like the spark test for cast. I don't like the spark test for every material, but with cast it's pretty obvious when it's actually cast iron. So that's all I got for today, and thanks for watching and subscribing to TV Weld. We'll see you next week.